All right. Good morning, everyone, and welcome to this talk, Serverless and Event-Driven Architecture, Good, but Can We Do Better? I'm talking about two of my favorite things as a developer, serverless, because I like it because it makes my life easier, and our lives easier as a developer when we can kind of abstract things away, and that's going to be one big part of my talk. And the other part is about event-driven, which I'm really enjoying as far as building applications, back-end applications using event-driven architectures. So I'm going to be going through these topics in 5 sections, and you can see this is section 1, and we'll just be kind of going through all these different things. So the first section is how fully serverless platforms is different from traditional serverless platforms, and I'm emphasizing the word fully serverless platform. So what do I mean by that? So one way to look at it is everything we do is built on abstraction layers, right? So there's a lot of different abstraction layers, but I picked these to kind of represent the runtime environment where things run. And we're going to abstract things away. So a long time ago, one of the big things we abstracted away was physical hardware. We came out with virtualization. We could take big machines and make them into smaller machines that have just the right amount of capacity for whatever the need is. And that was great, but the problem was just like with real systems, when you're deploying to it, the environment's different depending on which server you go to. So pretty quickly, we came up with the idea of containers. And containers are really nice because they give you that nice wrapping around your deployment unit to give you that consistency of the runtime environment. But pretty quickly, we started to run into some challenges here where we had lots of containers to manage. So what do we do about that? Well, the next thing that came along, and this is kind of a very brilliant invention from Google, Kubernetes came along. So Kubernetes is a many things. It's huge. It's a big part of, I think, many of us. If you're doing back-end systems, it's where we run our code now. It's become like almost like the intergalactic operating system for back-end applications. And the brilliant thing here is that it's a great environment for running containers, right? But can we do better and continue to kind of push the abstractions down? Can we hide even Kubernetes? Right now, we spend a lot of time interacting with Kubernetes. I know, like for me, it's the YAML this, YAML that, all these YAML configuration files to make things work. Next layer of abstraction is, and this is kind of right below the application layer, is things like databases and other services. A big one is like messaging, those kinds of services. And in a fully serverless environment, can we abstract these things away? So the goal is to have a serverless environment that's not just like, Amazon came up with the original Lambdas, back around 2014 or something, where the code was serverless. You just basically give your code to the AWS Lambda environment and it runs it for you. It scales and all those types of things. But here, what I'm talking about is abstracting away everything, and especially things like databases and messaging and all these other things that tend to become things that we have to be very concerned about with the types of things that we do today. It's a big part of our job often in integrating with these things. So this playing field is kind of this fully serverless playing field. And there's a number of offerings that are around for that. I've done other talks that kind of gone into them, and my company has, the reason I'm doing this talk is we have something like that as well. But this is getting to be more and more of a thing where you have these kind of fully serverless environments. And just a broad definition is you're just trying to abstract away as much complexity as possible on some kind of a software consistent development environment. So the next part, a big favorite of mine is, and I've been talking about these things for a long time, and now I'm actually, the last couple years or so, I've been actually able to really kind of sink my teeth into it as a developer, is event-driven. And just like fully serverless, I'm talking about pure event-driven, because there's different variations of event-driven that I see out there. So what do I mean by event-driven? What do I mean by pure event-driven? So this is a design diagram of a demo application I did. The diagonal boxes represent small, focused microservices. You can think of them like that. And they perform different operations. But in this diagram, what I'm trying to show is that the kind of the flow that happens in this type of an application, in this event-driven type of an application, where you have a service that receives some kind of request to perform some kind of an operation, some kind of a state-changing operation. And that, I'm highlighting here, this one service receives some kind of a request. Now, the lines that are highlighting going out of it, those are lines that there's some downstream things that are interested in the events that were published by this upstream service. So this is a real application. This is a real functional flow in this application. And I'll dive deeper into this as we go through the talk. But the idea is that that first service emitted some events that trigger another service to react to it. And that emits some events that other services react to. So this is the actual processing flow in this application, is this flow of this kind of cascading sequence of events that occurs while it's doing whatever the work is that this application is supposed to be doing. And it's quite interesting. It's quite a different way of thinking about how to break down complex problems into simpler problems and how to wire them together and things like that. But you can see the flow goes downstream, upstream. This is, again, real flow, and I'll show you a little bit more as I get into it. But the point is, this is what I mean by pure event-driven, that the processing flow is really event-oriented. The other interesting thing here is in this implementation, on this diagram, these are software components, and there are types of software components. So the diagonal box I mentioned is, you can think of it as like a small focused microservice. But there's also views, these V-shaped things that are in there. These are views that are done for queries of different types. And a third component is these actions. And these actions are like serverless functions that subscribe to events and take those events in and convert those events into commands that get sent to downstream services. So with these three components, I was able to design and implement this system, and it does some fairly powerful things that we'll see in a few minutes. But this is the behavior of this event-driven system using these three simple components. So the other part of this is that all the messaging that's occurring here is asynchronous, which is a good thing when you're building systems in distributed environments. When things are running on different machines and you're making all kinds of network hops and things break, they go down, they come back up. Asynchronous messaging is something we've been talking about for a long time with microservices as a good approach to do things. And this type of approach here, this pure event-driven, is all asynchronous. So all the messaging here is asynchronous. This is another thing we've been talking about for a long time with microservices. They should be loosely coupled, meaning that each service doesn't know about any other services. Each service doesn't depend on other services to do its work. This is really nice not only for design development and implementation and into production, because this loose coupling means that when you break the design, or it goes down in production, things like that, the blast area isn't quite as large as if things are tightly coupled. And tightly coupled is when you're doing synchronous request response times of coupling between services. So all these services are loosely coupled. This is a big part of pure event-driven, in that each service owns its own data, and the data is stored in event journals. So often you see event-driven systems where it's like the eventing is bolted onto the side. And what I mean by that is that the primary transaction that occurs goes into some kind of a CRUD relational database type of thing that we normally do with most, this is the traditional way we build applications. And then you'll emit an event. In this case, the data is the events, right? The views provide reference data, but the views are just projections of the event data. So each one of these services has a journal of events. And these views that you can see, they're kind of wired down below each service, are just projections of that event data into queryable views. This is a big one as well. That event journals you can think of as topics, meaning that you're publishing something into event journals, And it's relatively easy to set up something where those event journals are used to be, almost like Kafka topics, basically. Because Kafka is very well known and is very powerful and popular. But with pure event-driven, when your data is going in as these events, it's a way to make these things as topics on their own. You're not having to say write an event somewhere and store it into event journal and then put it into Kafka. Here, it's possible to do this messaging without having to have some kind of a message broker. So again, all these services have their own journals and they basically their own topics. So the result is that, this asynchronous messaging, this loosely coupled and so on, all these services run in a different time and space, which is ideal for cloud-based distributed systems. Each of these services are running, they could be running on different machines, and you saw kind of very briefly this cascading flow that's occurring where one service emits events that's consumed by another service. We'll say that the consumer service is down for some reason. The publishing service doesn't care because it's loosely coupled. It just keeps publishing events. When that consumer service comes back up, it picks up where it left off and starts trying to catch up with the backlog of things that it has to do. This is the example of being separated by time and space. So, third part of the talk, examples and use cases for these types of architectures. The design diagram that I showed you, it's a demo I wrote. I'm a developer advocate, so I don't have to write production code anymore. I've written production code for like 40 years, and I think I've did my time, and now I get to write code for fun. So, and it's a lot of fun. So I don't have that, the rigor of getting everything right for production. But I like to write demos that have some of the key characteristics of production systems, the things I've been writing for so long. So this Earthship demo, it started out as a simple e-commerce demo. Down at the bottom left, you can see there's this client, creating shopping carts, basically. So add item is an event, as a command comes in, add an item. An event is emitted, item added. Add another item, remove an item, change the quantity of item, checkout. So when a checkout occurs, that shopping cart service emits an event that there's a subscriber out there looking for that checkout event because that's a key event that creates an order. So got that part of the demo working. It's like, okay, that shows a little bit of event-driven, but that's kind of boring. So what I wanted to do was do something a little bit more interesting. And this is the reason why this demo is called Earthship, is that the UI for this demo is a map of the Earth. It's kind of like a Google map. And you can just pull it up on a web browser. You can zoom into any part of the map. And if you want, I can show you later, because I don't have time to do it here, but because I have it running on my laptop. But I can zoom into like where we are here in Warsaw. And this is just a simulation. But I can pick a circular region and say, all right, create a bunch of orders in this region. Because what I wanted to do is be able to create a lot of orders to put some load on the system to test the viability of this approach to make sure that this design could stand up to heavy loads and keep data consistent and not corrupt data and handle outages and all those types of things. So this is the way this demo works. So in the demo, a single HTTP request comes in the highlighted line at the very top left from the user interface. It goes to a service that starts generating random orders based on, you could say, create 200 orders, create 2,000 orders, create 20,000 orders, whatever you want to create. And it's going to, this one service is going to start generating random orders, and it creates, that emits events that are triggering the creation of what I call geo orders, which is an order at a geographic location, and that creates orders. Orders get broken down, and it starts processing the orders. And what happens in this application is it starts allocating stock to the orders at this point here. And it's all doing an event-driven, non-transactional sequence of events, types of flows. rigorous adherence to data consistency and concurrency controls and all those types of things. And so this application isn't just taking in orders, but it's allocating stock to orders. And it's allocating stock to orders in detail. It knows where every single physical unit of stock goes in this type of application. So it's not just decrementing, say, stock counters, it's actually physically tracking individual units of stock. The other thing it can do is that when there's insufficient stock, orders go into a back order state. Let me back up here. This triggers, there's insufficient stock, so that this triggers a back order. A back order, triggers, and again, this is a demo, so it triggers a stock order, orders stock. And when the stock comes in, the stock goes looking for orders that are in a back order state and hunts them down and fulfills them and allocates stock to the orders and things like that. So there's some really interesting behavior in this application with these 13 simple services here, relatively simple services here. And this was kind of blew my mind as I was starting to build applications like this, that this really interesting behavior was in it. So I want to do I wanted to visualize it. I love visualizing things. So this is a little movie that I made from logs from this demo application. So this is one shopping cart coming in. On the right is stock. On the left is the processing flow. So all these regions that are going to appear here are the different regions. So this is 200 orders coming in, and this is real data, processing real orders, finding stock, ordering stock. Stock comes flowing into the system. Again, that's on the right. And the yellow means these are orders that haven't been allocated stock. Red shows orders that are in a back order state. But what's happening here is it's triggering more and more stock flowing into the system. The orders get fulfilled. They all turn green when the orders are allocated stock. And then the red goes away because those were back orders that were there just in a back order state temporarily. I wish real e-commerce systems act like this. So these are the 13 services represented physically. So the lines, all these dots represent instances of these services. The lines represent event flows that occurred in this system. It was a lot of fun to put this together. It took forever to render it because it's a lot of data. But it was a very interesting way to kind of visualize the system. But that's kind of an indication of the behavior of these kind of event-driven types of systems. That's why I wanted to kind of visualize it in that little movie. So the fourth section here is how to build on fully serverless platform using pure event-driven. And so it's really the two parts. It's all about the abstraction layer. I mean, as I said, there's all kinds of different approaches that are starting to emerge from different companies and different open source and so on to keep raising these levels of abstraction to really kind of simplify our lives in terms of building back-end systems. And as I said, it comes down to just trying to abstract away as much of the infrastructure as possible to the point where you've got this new playing field. And for me, it was pretty amazing because up until I started using a platform like this, as a developer, I was always having to spend time, especially now in the cloud, developers are often responsible for setting things up in the cloud. So I had to learn about this service. I had to learn about this other service. How do I configure it? How do I make it work? I mean, it's really nice, and it's a lot easier than it was not too long ago, but still, it's work that I had to do. In this environment, what it means is that basically I'm designing and implementing my application and I'm giving it to the platform with zero configuration and say, run it for me. The platform looks at my deployment and it figures out how the persistent layer should work, how the messaging layer should work, how it should scale, deals with resiliency. All those types of things are being handled by the platform. At the code level, things get interesting as well because when you have these high abstraction platforms, it's a big responsibility is at the code level. So this is an example of a service, just a unit of service that is handling say a command coming into that service. So you can see at the very top is a command like create georder command. But the line I want to focus on is the one where the arrow's pointing. So just want to break it down. So you can see there's this concurrent state, but there's just this event for method on the state. So the state is really just an object. It's as simple as that. I said these services are simple. These services, in this case, are just focused on like single distributed durable objects, okay? The event for method, all it's doing is it's taking in a command and it's returning an event for that command. This is the way event-driven works. The current state method is actually an inherited method, in this case with the software development kit that I'm using here. But what's interesting here is the high abstraction that's happening in that to recover the state of an object with an event-driven system, like a shopping cart, add item, add item, add item, three events, check out a fourth event, maybe had another event that removed an item, another event that changed the quantity. All those events aggregate up to the current state of the shopping cart. To recover the state, you have to play back all those events. Well, and recover from the event journal and all that. This current state method did all that. So, as developers, we don't have to write that code. Some event-driven implementations I've seen, the developer actually has to write the code to do these things directly. It's not too hard, but it's just less complexity when you have an abstraction like this. But the big one here is a mid-event. So a mid-event is just saying, all right, persist this event. Now, with this abstraction layer, I don't know or care what the database is that's storing the events. I didn't set up the database. I didn't configure it. I have zero configuration for it. In my code, I have no code for connecting to the database or starting transactions, anything like that. It's all abstracted away. It's as simple as this one line. A min event for the event that's created from the current state for this given command. Done. Here's a little bit of an example of code. It's those actions that are subscribing to upstream events and pushing them down to other services. I'll show you a little bit more of this in a moment, but the thing I want to point out is at the very top, you can see there's an annotation that's just saying, I'm subscribing to events coming from this shipping order entity. That's it. So what happens here is that the platform is the thing that's retrieving the events as they come into the upstream event journal and making calls to this action. So all that plumbing is abstracted away. Often we, as developers, have to deal with that plumbing today. And then what's left is that the second arrow is pointing to a method that I just call on event, make this call. Basically, call this downstream service. So I'm taking an event, converting that event into a command, and then sending it to a downstream service. So what it comes down to, really, it's the fun part, I think, is the design of these types of event-driven systems. This was a really interesting process for me to wrap my head around. This is different compared to like traditional systems. But it's not that hard. And I think it's getting better because as more people are getting familiar with this, there's more material that's out there to help people come along more quickly. But this whole thing of designing the system, you're thinking in events and you're decomposing problems. Like I got a order that creates a shipping order. The shipping order's got, has a list of order items. So this actually gets broken down. So instead of having a service that's kind of monolithic that handles the entire order, all the order items and allocating stock to each order item, all that in one single service, there's kind of a series of delegation that occurs here through event-driven flows. So a shipping order emits an event that creates n number of shipping order items. And I actually take the stock from the order items and break it down to this stock level so that this is where stock's getting allocated to these order items. And as stock gets allocated and the order items are fully stocked, they report up to the order, and when all of its order items are fully stocked, it updates back upstream and says, hey, the order's ready to ship. That's the flow that's happening in the system. Again, just these three simple building blocks, these entities, actions, and views, and just this basic event flow. But here's what really kind of blew me away as well, and I hadn't seen this before in systems that I designed, is that I'm calling them kind of like event-driven patterns. And there's a number of different patterns that just kind of emerge as you start to get into this. So the saga pattern, I think everybody's probably familiar to some degree and maybe using it, but there's actually two flavors of the saga pattern. There's the orchestration saga pattern, which with orchestration, there's some kind of controller that's controlling each of the steps. It's kind of like a workflow. Step 1, reserve the flight. Step 2, reserve the hotel. Step 3, reserve a car. So there's some kind of controller with that. With choreography sagas, there is no controller. It's the natural flow that has the sequence of events and controls it. Now there is, you do have compensating actions and things like that, but it's a different way of doing things. This entire Earthship demo is a big, huge choreography saga pattern, basically. And I like to think of it as deep eventing. So a lot of times I see people doing eventing, like event-driven, but they only just kind of get into it. You don't get into like, this service emits events that triggers another service, and that service emits events that triggers another service, and you have these flows like the way this system works. Another pattern is in these actions. There's of the 25 or so actions in this design, 5 of them are what I call one-to-many, which is an event that contains a list, like an order contains a list of order items, and that breaks down into the event or the action sending out multiple commands to multiple downstream services, instances of downstream services. There's 5 of those in this design. Another one I call generation loop, but this is where a service or an entity is emitting events that loop back on itself. So it keeps itself doing some work until the work is done. So it's kind of a form of a loop. Third one, and this is very powerful, I call it a reduction tree. So basically, this is a way to aggregate or reduce data. So the leaves of the tree are like raw data that needs to be summed up or aggregated or reduced at the trunk. So this is exactly what these 3 services, of the 13 services in this design, 3 of them are these reduction trees. So repetition of pattern is what is pretty interesting here. You learn how to do a reduction tree once, and all of a sudden you see all kinds of different places to use it. The result of this is a very significant reduction in context switching. And we often hear about context switch. It's like you're in the zone, you're working on something, and then something or somebody interrupts you, and you often read about it. It's like takes you a half hour to get back into the zone again. And this is, not like my wife coming into my office at home when I'm working and say, hey, I want to talk to you, and I'm out of my zone. I got a context switch to her, or she's going to get mad at me. It's also the context switching, like I'm in the code, but now I got to start thinking about Kubernetes, or I'm in the code, and now I got to start thinking about the database, or some infrastructure stuff, or some server, or some configuration setting, something like that. It takes me out of the design thinking mode, or it takes me out of the coding mode. And this context switching, this is really, it was a big kind of revelation to me that it didn't occur to me until I kind of got into it. It was like this, wow, I'm really kind of moving here because I'm doing a lot less context switching to other stuff that used to distract me from getting stuff done. So very quickly, I just want to show you another application. Just written, I call it Transactor. This thing is handling high volumes of transactions coming in from a Kafka topic. And the main thing it does is the funds that are coming in from these transactions have to be reduced down to what are merchant payments. And merchant payments are basically just moving money from one account to another. So that's what this application does. But it's very similar in those patterns that I just quickly talked about, the reduction trees, the one-to-many. Those types of things are in this application as well. But here I wanted to show you kind of one of the more complicated parts of both of these applications, the Earthship and this Transactor application. If you look at these 2 sections, the Earthship, this is where stock is being allocated to orders. With Transactor, this is where deposits are being consumed by withdrawals. But the wiring is similar. The processing flow is similar. This is kind of a mutually agreeable series of state changes that occurs. It's a reusable pattern. Again, these things keep popping up. So how does this impact development? Well, going into these components, I want to show you just a little bit of code. This is one of these entities. It's not very complicated. A few annotations. It's got an API. But the thing I want to really show you here is like this line. You can see there's an annotation for a post mapping. But there, on this line here, this line 44, emit event, current state, event for command. Go down to another one, ready to ship. And same thing, emit event, current state, event for command. So it's just kind of a cookie cutter. And then another part of this is that once the events are emitted to the event journal, when they're successfully committed to the event journal, then these event handler methods are invoked. So on this event, it's just doing a current state on event. And you can see the return is the altered state. So in the event for is emitting an event, but events trigger state changes. So that's the way this flow works. But it's just kind of cookie cutter, handling the APIs, handling the event handlers, and then the actual state, and I just call it state, it's just a record. I like a Java record because it's immutable. It has some attributes. What are the attributes of this entity? But then here are the event for. Like here's the event for method for create, ready to ship. You can see it's just returning events. The logic here isn't really complicated. And then this is the event handler methods. The nice thing about the state is this is pure Java. It's like there's no need for any other libraries. It's just simple, pure Java. It's kind of agnostic, which is nice for testing as well. But it's just this pattern. Every entity, you look at the source code of this project, if you look at every entity basically follows this flow, which is great for AI coding assistants like GitHub Copilot loves this kind of code. And all the commands and events are just records. So I'm going to have to move along here. Let me just show you a view real quick and then I'll wrap up because we're just about out of time. A view is similar to a subscribe to the events we want to project into a view. And then, oops, that's an action, sorry. Subscribe to events that need to be projected into the view. Define a SQL statement that's used to pull records from the view. It's just, this one's a little bit more complicated, but not too bad. And then event handler methods. So these are methods that are handling events that are being projected into the view. It's very cookie cutter as well. And then finally, just real quick, here's a couple of actions. I'm just going to flip back and forth to show you that the arrow is, this is a one-to-many action. It takes in an event. That event has a list. It maps the list items into commands. It maps the commands into calls. It collects all those calls, which are just futures, up, and it waits for all the calls to complete. And you just look at these two actions, and they're basically just a variation on a theme. Really simple. Real quick, this is an example. I caught it from another presentation. This is a screenshot, and there's two lines that got arrows on it. The one line says save state async, and then a little bit further down, and this is one method, I think it's C# code, is publish event. And there's a problem with this code. Anybody see what the problem is? The problem is there's a leak here, in that what will happen is that you could run this thing millions of times and it'll successfully work. Makes a change to a database and then publishes an event. Makes a change to a database, publishes an event. But then every once in a while there'll be a failure right after the save state occurs, but before you publish the event. This is non-transactional. So what this means is every once in a while you leak events. And if those events need to happen, They didn't. I've been in this kind of situation. It kills you because your business sponsors find out, your customers find out, your managers find out, and they keep saying, have you fixed this yet? Have you fixed this yet? And you may not even know that this is where the problem is in code like this. So the point is that what some of these newer solutions are doing are trying to make it easy to do things right, not write that code I just showed you, and difficult to do things wrong. So it's kind of by definition, the architecture is kind of guiding you in the right direction. So that's it. I'm out of time. I covered the 5 sections. Fully serverless, and what that means is you're abstracting everything away. Pure event-driven, where it's not bolting event-driven on the side like that quick example I showed you. Your data is the events. It's not just a kind of an afterthought. Use cases, some people say, maybe this isn't the right problem for event-driven. I don't know. Often I think that event-driven solves many problems that many people might not think that it would. And then just building on fully serverless platforms, that lack of context changing and things like that. And then the productivity that comes out of it. So the product I've been talking about for my company, just a quick little commercial, is called Calyx. This is a QR code that'll take you to it. You can try it out. It's a platform as a service type of solution. But if you're interested in playing with this technology, you can try it out and run it locally. You don't have to sign up or anything like that, and just give it a try. I love it. It's very cool. I want to leave you with this. I use this in a lot of my talks. This quote from Alvin Toffler: "The illiterate of the 21st century do not be those who cannot read and write, but those who cannot learn, unlearn, and relearn." And the reason to bring this up is the stuff I showed you here is different. It might not be what you're used to. And you might look at it and go, man, should I really do this or not? I've learned that when my instincts tell me, oh no, I shouldn't look at this, it's 180 degrees wrong, that I should look at it. And I've kicked myself so many times for bypassing something new because my instinct told me not to do it. This is what Alvin Toffler was trying to tell us. So with that, the slides will be available, but if you're interested, here's the QR code in the top right is for the slide deck, and a QR code, and there's also a QR code back in the slide deck for that Earthship demo, the GitHub repo. Thank you very much. I'm sorry we're out of time for questions, but I'll be here for any questions you have later.